I'm Ralph Spillinger. I'm the chairman of the facility committee for the Bainbridge Island Museum of Art. I've got a background in large-scale construction. The last 30 years or so before I retired, I worked for NASA and for the Navy managing large construction projects. And when the opportunity came to do the same thing for the Bainbridge Island Museum of Art, to ensure that we have a structure ultimately that is capable of the full potential of what this museum represents, I jumped at the chance to join in and help out. One of the primary goals that our committee set for our museum is to achieve a really high level of energy efficiency, earth-friendly design, and sustainable design. In fact, we've set a challenge for ourselves that our museum will be awarded a Gold LEED award upon completion. The LEED system, and that stands for Leadership in Energy and Environmental Design, is a internationally recognized standard by which buildings are measured for how successfully they achieve those characteristics. In the museum world, it's extremely unusual to see a structure achieve the gold level. Museums are energy hogs. They require an awful lot of energy to protect the valuable, vulnerable, and fragile artifacts that are often displayed, and to make the environment comfortable for the visitors to the museum. I only know of a handful of museums in the United States that have been successful in achieving a LEED Design award. We're setting that challenge for ourselves, though. In order to do it, we know we're going to have to probably use something as innovative as geothermal, and that's what I'd like to take a moment or two now to describe to you. Now, behind me are traditional heat pump air exchange units that were recently installed for an office building that was constructed adjacent to our museum site. These are state-of-the-art. This is as good as it gets today. These units are probably about 50–60% more efficient in heating the building than the traditional use of oil or gas or electric heating coils. Nonetheless, if we're going to win a gold award, if we are going to be as energy efficient as is currently possible with the state-of-the-art, we knew we'd have to take it up a notch. This trench I'm walking through is in the midst of a geothermal well field. We've just finished drilling 14 individual wells ranging from 350 to 400 foot deep that are the heart of our geothermal heating system. Traditional air exchange heat pump units behind me work by pulling heat out of the atmosphere and pumping it into the building in the wintertime. In the summertime, they work in reverse. They pull the heat out of the building and exchange it into the atmosphere, working very similar to how your household refrigerator does. Now, in a geothermal well system, instead of relying upon the air as the heat sink, we use the earth itself as our heat sink. These pipes are on top of one of those 14 wells. Geothermal heat systems are more efficient for two reasons. Number one, the earth is a much more efficient conduit of heat transfer than the air is. Number two, the temperature of the earth, once you get below about 6 foot, is much more stable than air temperatures. The earth temperature below 6 foot is a constant 52 degrees year-round. The way our system will work, we will pump water from the building through all 14 of these wells. In the summertime, the water that will be pumped out will be quite warm because we'll extract heat out of the building, pump it through these fields, and exchange it into the earth. In the wintertime, we do a reverse cycle. We pump the warmth out of the earth into the building, concentrate it, and use it to heat the interior spaces. The end result is about a 50% increase in efficiency over the traditional units that are behind me that you rely upon the air for that exchange of heat. Well, the hard work of the geothermal well field has been completed with the installation of the 14 wells. The remaining work is simply to take the pipes that come out of the top of all 14 wells, to combine them into a single manifold and bring them around through this trench over to the foundation wall of our museum. They'll run through here into the mechanical room and into the mechanical portion of the heating, ventilating, and air conditioning system. The challenge of achieving a Gold LEED award requires some really creative thinking. We're probably going to be doing something like 100 different initiatives in order to be successful in the outcome of that award level. This is one of the biggest, the geothermal heating system, but again, it's only one of many steps that we're taking.